What drives me as a researcher is to discover new knowledge, to discover fundamental principles, to understand nature. On top of that, I'm fascinated by projects that actually help to solve world problems. Like, for example, to understand how nature converts sunlight into energy, or how we can understand materials better that are used in solar cells. The goal of my current research is to film molecules and atoms. To do this, we are developing a new experimental method, and this method uses high-intensity X-rays and modern laser technology. I think once the method is developed, there will be many applications, but I'm focusing on two applications at the moment. And the first one is to study materials that are used in novel solar cells. And we want to understand how they absorb the energy that is given to us by the sun. And by understanding better how this process works, we hope to give important input back into research so that others, engineers and other researchers, can develop better materials to make better solar cells. The second applications that we are looking at is cell membrane fusion. Cell membrane fusion is actually extremely important because it happens in our brains every time we think, and we sense and we feel it. With the help of the new method that we are developing, we are hoping to be able to film cell membrane fusion for the first time. And this would then in the long time be very useful for understanding diseases such as Alzheimer or diabetes, where cell membrane fusion is an integral part. I think in this particular project it will take us 2 to 5 years to establish the method. And then it will take 5 or 15 years maybe for applications to materialize so that the method gets used by us and also other researchers to study important chemical reactions. One moment that I clearly remember is when I took a coffee break with a fellow PhD student in Cambridge. This was approximately 5 years ago. We were sitting down in our lunch corner, drinking a coffee, and we were talking about our research, about our data. And suddenly we had realized that we had developed a completely new research project. And not even that, we also realized that we had already measured all the data for the research project. So this was exciting because everything was left to do was to set up a model, to analyze the data and to write a publication about this project. Everything happened in just 10 minutes in this coffee break, and it is absolutely impossible to say who had the idea first. I think this is why I remember this moment so clearly, because it was a moment of mutual creativity, which are very rare in life, I think. My motivation for being a researcher is to understand nature, to understand fundamental principles around us. One example comes to my mind when I think about how basic research and applications are connected. And this is actually the GPS system that we are today using in all mobile phones, and in many cars are equipped with a GPS system. And it turns out that GPS would actually not work without the help of the theory of relativity, which Albert Einstein developed almost 100 years ago. I don't really think that Albert Einstein knew that this would be important for the GPS system. He probably just developed the theory out of interest to understand the fundamental principle. But this is a good example on how basic research can transform into real-world application many years later after the discovery is made.